Welcome to Section 2, Value Streams and Processes of the Problem Management Practice. Of the 20 questions in the exam, 5 questions will come from this topic. This would be a mix of understanding and application questions. The process questions would be understanding type, and the value stream questions would be application type. But we do not know how many would be exactly the understanding and how many application. So therefore, Section 2 and Section 1 together make up 10 of the 20 questions in the exam. Section 1, however, has only understanding or Bloom's level 2 type of questions, no application questions. In this section, we'll be covering the processes and the value streams for the practice. And there are 4 processes, so we'll be looking at the inputs, outputs, and the activities of all the 4 processes, and also the sequence of the activities in these 4 processes. And then we will look into the contribution of the problem management practice into the various value streams of the organization. And also, there is a technique for the value stream analysis. We will be going through that as well. As I mentioned briefly earlier, there are 4 processes in this practice. You might recollect the 3 phases of problem management. They were problem identification, problem control, and error control. So we have essentially those 3 phases converted into 4 processes, because for identification, we have proactive problem identification and reactive problem identification, which you already know. And then we have the same problem control as a process and error control as a process. So the first 2 processes take up the identification phase, and then afterwards we have a process each for the problem control and the error control phase. Let's dig into each of these processes in more detail. Firstly, we have the proactive problem identification process. As you know, this is applicable for identifying potential errors in the organization's products based on sources other than ongoing incident records or past incident records, which means that there could be some vulnerabilities, some risks in the existing products and services, and that is the focus of the proactive problem identification process. Therefore, the practitioners will identify, assess, and analyze the vulnerabilities and associated risks in order to identify such problems proactively before they can investigate and do the error control or the solutioning for these problems. For each of these processes, we have a table of inputs, activities, and outputs, and followed by detailed explanation of each of the activities. It is important for the exam that you remember the inputs, activities, and outputs, and also the sequence of the activities, and also what happens in each of those activities. And we will be going through them anyway. So the inputs here are, in general, most of these inputs are common across all these 4 processes, but I will be highlighting any unique ones for specific processes. So we have here, because it's a proactive identification, you might recollect that there are many sources of inputs for proactive identification of problems. And for example, we have here a key inputs, error information from vendors and suppliers, information about potential errors submitted by specialist teams, information about potential errors submitted by external users and professional communities, and also those submitted by users. Then we have 2 special ones here. The monitoring data can also be useful for proactive identification of problems, and also service configuration data that can help to understand a little bit about the problem, not investigate, but at least to categorize it and to assign it. And therefore, the activities here are reviewing that submitted information or the inputs, then registering the problem, logging, that is recording it, and then do the initial categorization and assignment. Of course, there can be some initial urgency and those kind of assessments, impact assessment also, but generally those will be more confirmed during the problem control process. And even the categorization and can change in the problem control process afterwards, because this is just the initial categorization and assignment. The key outputs here are the problem records themselves for each problem proactively identified, and feedback to the problem initiator, particularly if it's a problem that was raised internally, not through external sources such as communities and so on. And the feedback would be mainly whether the problem was registered or not. This is a workflow diagram for this process, and you will see a similar diagram for all the other remaining three processes as well. This uses a standard notation called Business Process Management Notation, or BPMN. You can find several sources of that on the internet. It is not important for us to understand that notation. Essentially, if you look at these symbols, these are the inputs to the process, the triggers to the inputs, or what triggers this process. And then you see the three activities. And in this that we saw in the table earlier, the three activities, they are shown sequentially here. And then you also see an arrow going from the first activity, review of submitted information, directly to the end of the process. Meaning, if there is no reason to register problem, then this process can end. There is no need to, once the review happens for the submitted information, for the proactive inputs, that is, no need to register or categorize and assign. But in other cases, it would be registered, categorized, and assigned. And also look at the information that is coming out of each activity. When the information is reviewed, feedback can be given there itself to the initiator. If they are an internal initiator rather than external, they would like to know what is going to happen with their input. Then the problem record is created. And then you see here at the end as well, there is feedback to the initiator that yes, their problem was registered and assigned, unless they are an external initiator and they would not be made aware of it. A little bit more before we look into those activities individually. And we have seen this from the inputs in the table itself, the sources of information for proactive problem identification. These can be service designers, developers, architects, and other teams. And essentially, they would be aware of, or maybe they detect or suspect errors in the current live versions. These are not incidents that are on, but something which could go wrong. And so they could detect some errors likely to occur in currently deployed live environments. Or they might have been doing some testing, but not fixed errors yet. Or when they're working on subsequent version, they might detect some errors with the current version. Then vendors of software and other CIs, configuration items, that is, they may be able to detect or suspect some errors in the current live versions of their own vendor systems and components. Users and professional communities through various websites and portals, they might be familiar with similar errors from products and services of other organizations that are very similar to this product or service, and are using other organizations might be using the same service or product, the same version as well, and they could give some good inputs. Monitoring data can help practitioners, technical practitioners, suspect trends and deviations in the performance of services and CIs. For example, there could be certain alerts coming out always from a certain network link or certain server or a storage box or application and so on. Users, we have seen that before, but once again, users can always point out vulnerabilities in the service they are currently using. They might feel that, hey, I sometimes do see an application slowness. Everything was generally okay, but I don't know. I just wanted to report it to the folks, and maybe that can cause a bit of suspicion, even though there is no ongoing incident yet. And there are some good guidelines here coming up for this process. Even in the proactive identification of problems, so the focus should be initially on the key systems and components where the impact could be much higher to the users and customers. But that does not mean that other errors should be ignored. They should also be looked into at some point in time. And the challenge in modern environments and business environments is that the environments are quite complex technically. For example, they have high availability. And sometimes an incident analysis may be difficult because they may have multiple causes. Even though we are currently in the identification step, not in the problem control where the investigation analysis occurs. But then the point here is that during problem management as a whole, there may be some errors which are happening which seem to be very small, and that can actually lead to serious incidents. I remember in one case, for example, um, I received an error when I tried to access a website, an application website of a service provider. And the error message that I saw was the HTTP errors, of something like 429, which means due to security reasons, my access to that website is not allowed. But as if, I'm a hacker, but that was not the case. So I just happened to casually have a conversation with somebody who was from the web team. And they actually made a serious note of it. And they found out that even though it says one instance for me and maybe a few others only, nobody else reported it as such, or even formally it was never reported. But they found out it could have led to a more serious incident wherein a whole lot of users could have been blocked from that website of their service. So that's an example. And so such proactive problem identification should include initially itself a careful assessment of the probability and impact of these vulnerabilities, as in that example, before it goes to problem control. Now we have the three activities coming up for this process. The first one is to review the submitted information. So generally, we will have some specialists or a group of specialists reviewing it. They may check for duplicates, or is this something that we have seen earlier? Is this really a problem that we should work on? Is it worth looking into this? Is it too minor, that is too small to be bothering anyone? And they will also check whether are there any ongoing incidents which could be related to this proactively coming in information. And there may be some cases where they may not want to register the problem, and therefore the initiator could be notified, particularly if they insist that they be notified, which is a good practice to notify them. But if the information came in from external sources through community or other bulletins, then no need to notify them. It may not be even possible to know who put that input on a certain portal or through some social media, for example. Next, the problem is registered only if there is a need to analyze it and to take it through problem control as the next process. Then it will be registered. And it can be done by somebody who is dedicated to do that, or it could be done by a specialist as well. If we look at the roles for this practice in a subsequent section under the organizations and people dimension. Then the third and last step of this process is to do the initial problem categorization and assignment. The word initial is important. And whoever is registering the problem in the previous step will do this categorization. And essentially, they will have to note down or document the following in the problem record, such as the source of the problem, its description, are there any suspect configuration items or components or categories, estimated impact and probability of incident occurring due to this proactive input, and what could be the services that could be affected, and what could be the impact on the organization and its customers and users. And then so this will complete this process. And just one last thing here, it will be assigned to a specialist group as part of this process itself during the identification. But that assignment need not be a perfect one. The categorization and assignment may be a bit weak, but it can be always modified in the next process of problem control. And again here, the problem initiator may be notified that their problem has been registered. So then we have the next process, which is reactive problem identification. Very similar, except that there will be no review of the proactively submitted information in this case, because this is about information about past incidents and ongoing incidents. The past incidents can be useful to detect certain trends. Ongoing incidents will be requiring usually more immediate attention depending on their priority. And so therefore, incident management and problem management go together as part of a value stream. And the same people may be involved in both incident and problem management. In the section 1 example, I have shown you the connection between incident and problem, where an open incident record may lead to opening a problem record as well, if incident management is not able to put an immediate workaround or a known solution already. Or when there is a solution available, but the incident is recurring, then maybe that solution was not perfect, and therefore a problem record will need to be opened. So for past incidents, there could be some kind of analysis done in terms of volume of specific category of incidents that are happening. What were their impact? Is there a trend of a specific technology or type, like for example, a database type of incidents, or it could be certain supplier type of incidents, therefore need to open a problem record. Remember, problems are not only for technology, it's also for organizations and people dimension, partners and suppliers dimension, and value streams and process dimension as well. So, and the process is the same, but there can be slight twist to it in terms of how it is applied, uh, based on whether it's an ongoing incident-based problem or a past incident record analysis-based problem.